Hello, everybody, and welcome to episode 165 of I Wish You Were Dead, a podcast about things that used to be alive. My name is Fia, and that is Gavin. And Gavin, did you know that some fish sound like popcorn?
Not specifically, but that doesn't surprise me. As you sort of alluded to a number of times, the ocean is quite noisy.
Yes, so today I'm really excited to dive into some of the cooler, lesser known areas of marine science, hydroacoustic ecology. But first, we have some stuff to talk about.
Yeah.
Gavin, do you have any housekeeping?
Sure, we'll do a housekeeping, and then I'll do just a real quick, another administration science-y type thing update. Not a real long one, but do not forget to rate the show on whatever platform you listen to us on, and make sure to follow us on Twitter, Facebook, and YouTube to give us feedback about the show and to suggest any future topics you'd like to hear on the pod. If you'd like to be a guest on the pod, be sure to fill out our guest form, which can be found down in the show notes. As for next episode, for the first time in like almost 2 months, I'll have to actually prep an episode instead of just if you've listened to the last couple episodes, it's just been my wife and I watching dinosaur documentaries and talking about them, which was fun, but not a lot of work, thankfully. But yes, we're going to be talking about viviparity, which, if that is a new vocab word for you, don't feel bad. That is the scientific word for basically giving live birth, having the embryo develop inside the mother. Very topical for my life currently.
Yes.
Anybody who's been listening to the show for a little while will know that I just had a baby. Yeah. She's very cute. She's doing very well. Both Liz and the baby are happy and healthy, which is really great. We're very thankful for that. And viviparity is a really fun concept because most people traditionally associate it with pretty much just mammals. And mammals, I think, are the most famous for it, most famous like individual group. But there are tons of other animals that give live birth.
Yeah.
So we'll be talking about that in 2 weeks.
Stingrays.
Yeah, very famously, a lot of sharks and their relatives do,
Mm-hmm.
as well as many other fish, many reptiles, even some weird insects or arthropods and things. So we'll have a lot to talk about. Spoilers for episode 166. Yeah.
Exciting.
So real quick, also just administration things. This one is only like vaguely tangential to science, but it's about museums, which is not necessarily like science, but it's very paleontology. A lot of paleontology cannot happen without museums. So the Smithsonian Institution, one of the most famous museums, arguably in the world, for sure the country, the United States. The exhibit that they have on presidents, there's a whole museum about like the presidency. They just recently removed the information about President Trump's 2 impeachments. And the reason that they gave is, I will say, one of the more plausible things for like trying to cover up something like this that the administration's done in these last 8 months or so. Basically the museum exhibits are generally very cumbersome and generally very expensive to update, which is why when you go to a museum, you might see some things that are relatively out of date. As much as they try to be educational spaces, a lot of information just updates so fast that it would be incredibly unpractical and expensive to update them every time we got our scientific understanding got better. I'm thinking in the lens of like natural history museums. And so the information about the impeachments was like a temporary like addition to like the exhibit on impeachments about the previous presidents that have been impeached, and also Nixon, who was almost impeached but resigned before it got there. But so it was just kind of this additional piece of signage that was kind of tacked on. And basically they said that they're in the process of now updating it, like, fully. Frankly, this administration has not done a lot of things to instill me with trust, so I don't really feel the need to give them the benefit of the doubt on it. And while I don't think that this is on, the president's radar, per se, whoever's running the Smithsonian currently, which for all I know is Marco Rubio, the Secretary of State, and also National Security Advisor, and also, like 1,000 other jobs that he just gets given because he's not actually the Secretary of State. It's a long story. But yeah, for all I know, somebody just walked by this and saw it, like, and was like, I don't think the president would like that, and got rid of it. And the fact that that is something that I think is extremely within the realm of possibility of this administration to do is to just say, oh, the president wouldn't like that, even if it's accurate or adds context to this exhibit, I'm going to get rid of it. The fact that that is not something to be like, oh, no, he wouldn't do that. Sucks.
Yeah, it does.
And it's just another way on top of various things that we've seen within the National Park Service, how they're getting rid of various additions or signage at Stonewall National Monument about the LGBTQ rights and movement and everything like that. The fact that they're just changing a lot of signage to sort of comply with this president's administration's worldview. This seems very in line with that. So, unfortunate, but the anti-woke, anti-science stuff is fully making its way into museums, unfortunately. And this is just another example of that. So, fun times with that out of the way. So with that, Fia, tell me about all the sounds in the water.
Yeah. So I just want to break it down first to talk at its most basic level. Hydroacoustic ecology is basically the study of underwater sounds. So both how animals make sounds, but also how they respond to sounds. And how we can use that sound to learn more about marine ecosystems. So it's kind of like listening to nature's secret conversations.
Yeah, so we, I've lived in fairly natural, as natural as, Eastern North America can currently be, places most of my life. And if you sit outside, especially in, spring or fall, you hear a lot of stuff all the time. You hear frogs, you hear birds.
Exactly. Yeah.
But we don't really think about that with the ocean because, most of our experience, the general public, our experience with being underwater is in pools or places like that where there's nothing to make the sound.
Exactly. Yep. Yeah. So, like you said, the ocean is loud. It has a lot of things that you wouldn't think are there, but just like how in the terrestrial environment, there's frogs, there's birds and all that. The ocean has that too. So some specific examples that I'm thinking of when I'm working in my seagrass meadows, there's tons of little snapping. That's some snapping shrimp that are just popping away their little claws and making that noise. And there's also toadfish, which to my ears when I'm underwater sounds like a little phone buzz like this.
Oh, okay.
And I've actually had friends when we're snorkeling are like, oh my gosh, it sounds like there's a submarine or something making some noises. And I'm like, oh no, it's actually just the toadfish. And so yeah, there is plenty of noises that are happening underwater all the time, but there's the natural sounds too that we don't think about, like the waves and the rain, but also the fish. They'll make grunts, drums, and pops. And fun fact, snapping shrimps, they create those snaps that are loud enough to interfere with submarines. Which is pretty cool.
So when I was down in Belize in college for a marine biology class, the one thing that they made sure to tell us about, because it is when you're on reefs anyway, one of the most jarring is parrotfish.
Oh, really?
So parrotfish eat coral. And if you've ever looked up or looked at a parrotfish, they have like shockingly and like scarily human-like looking teeth.
Yeah. Very like molar-like.
And so they just chomp right on the coral, and it's very loud. So as soon as you get underwater, you just hear like a constant like popping and like crunching from parrotfish, and like you might not even be able to see the fish, but it's somewhere in the reef just munching on this coral. But yeah, so it's all sorts of little things.
Yeah. And there's also non-natural sounds too that you can hear underwater, mostly created by humans. So there's boat engines, sonar, and drilling. Something to know about noise in the water is it travels faster than in air. So everything kind of seems louder and closer than it actually is. So when I'm in the water and I hear a boat noise, I'm like, I have to train myself to be like, okay, like it's not as close as you think it is, but I still end up looking up and being like, where's that boat? And sometimes I don't even, it's too far away to even see.
Yeah, it's sort of the opposite of like the little sign on your mirror in your car. It's like objects in mirror are closer than they appear. Sounds in the water are farther than they sound.
Yes, exactly. Yeah. Okay, so what kind of fish are we talking about? We're talking about, like I said, toadfish, but also drums. They'll produce low frequency sounds that attract mates, or they'll also do it as a defense to their territory. They'll be like, hey, like, I'm here, leave me alone. Groupers and snappers will also make some short booms or knocks during their spawning season. And that's also like a communication mechanism. And then, then we have like the inverts too that are also making those snapping noises. And the snapping shrimp, that snap usually comes from a little air pocket between their claw, and it's actually like they're using it to stun their prey. It creates this force that will like knock out or like kind of confuse some prey that they're
I think some whales do something similar with their echolocation. Obviously they use it to like talk and find each other, but I think some of them will also just like scream at a school of fish, and it disorients them sort of as well as like everyone's sort of vaguely familiar with like whale calls from like very far away, and they talk to each other across like whole oceans.
Yes. And so while that is probably like the more recognized form of hydroacoustics, I wanted to kind of dig deeper into a little more of like the stuff that people aren't really thinking about hydroacoustics. So we've got who makes the noise. We know fish, inverts, and the environment, waves, rain, boat noises. But in terms of the natural sounds, why are these animals making noises? What are they saying? Most of it is for communication, specifically for spawning, territory defense, warning calls, or navigation. We also have found that many fish are more active at night, and so sound is a great way to stay in touch in the dark. But specifically, during the crepuscular periods, which is dawn and dusk, that is when you'll often hear like almost like choruses, like snapping shrimp choruses, and they're kind of communicating with each other during these periods. We've also seen that fish, particularly during their mating seasons, will be more vocal during the full moon and new moon. yeah. And so, and then specifically dawn and dusk
Hmm.
as well around that. And so, yeah, again, like they're just talking to each other and using those cues and the environment to help let them know when everybody should start talking.
Hmm.
And then another thing is that a lot of larvae will use sound cues to locate healthy habitats. So this is like this brings me one of the examples I wanted to talk about today. Oyster larvae, they'll listen for sound cues from a healthy oyster reef, and studies have shown that they actually will prefer or like select going towards those habitats that have the healthy
Hmm.
soundscape.
That's
Yeah.
interesting. I get that makes sense though. That to the
It doesn't
okay,
though,
okay.
because they don't have ears.
Right, but when you're like, especially
Yeah.
the larvae, when you are, you know, you don't have a shell yet, so you are basically just like
Mm,
a enclosed water sac, more or less.
yes.
So like your
Hmm.
whole body is kind of in ear at that point.
Right,
Uh,
right.
but yeah, it's interesting. But I guess that makes sense that that not just the oyster larvae, but larvae in general would kind of do that because I'm
Yes,
sure there is
exactly.
just like a combination of sounds, whether it's like fish fry, sort of like listening for like
Yeah,
waves on mangroves. I'm sure that makes a particular set of sound that they can, you
yeah.
know, go toward a little better. I don't know how well a lot of them can like swim. uh but
Right, right.
maybe it's something like in the case of oysters where it's like, oh, okay, I'm getting closer to this sound. Maybe I'll start producing my shell a little quicker now.
Hmm.
But no, that's
Yeah,
really cool.
yeah. And okay, so moving forward, how do we use hydroacoustics as scientists, as humans for research? So there's two main ways we can do this. One is through passive acoustics. This is just listening and recording with underwater microphones. These are also called hydrophones, hydromoths, audio moths, a bunch of words that we use to call underwater microphones. And then we also have active acoustics, and that's sending sound pulses and measuring the reflections like sonar or fish finders.
Okay.
And I'm not going to talk about any of that because I don't know much about that, but I want to talk about passive acoustics because I think it's really cool and it's becoming like a real up and coming tool for how we measure fish biodiversity and a lot of um potential for like fish monitoring. So, what can we use passive acoustics for? We can detect when fish are spawning by listening for their calls. We can also measure biodiversity by analyzing the background soundscapes so we can look for the number of different kinds of fish calls. So different fish will call in different ways. Like I said, the you've got the snapping shrimp that make the snaps. You've got the toadfish that make those grunts. Um, some of the croaker and snapper will kind of croak almost. It sounds more like a "Rah, rah,
Okay.
rah." Uh, and so you can put these underwater microphones down in a environment and kind of see, okay, there's this, and this fish here, but in other places they only have this one fish that we're hearing, you know? And so that can be an indicator of how we track a healthy reef or mangrove key or seagrass meadow over time.
Hmm.
And so this brings me to one of my dissertation chapters, which is called Sound and Sight, linking habitat connectivity and fish biodiversity using visual and acoustic monitoring in Florida coastal habitats. So, a lot to say, but basically, I am looking at two different kinds of sampling methods for fish biodiversity. Traditionally, what we've used to like look at fish biodiversity is called an underwater visual census. And that's where you're underwater with your eyes and you're looking at the fish and you're counting the number of fish and you're IDing the number of fish. And so I'm doing that in areas where I'm also deploying hydromoths, the underwater recorders, to listen and see if I can't capture the vocalization patterns there, to look at the number of calls as well as the number of types of calls. So while I can't exactly say, okay, there's like 100 fish here, because with acoustics you can't really define like individuals. It gets like kind of tricky knowing who's who without being able to see it. But you can say like one habitat is louder than the other. Yeah. And one habitat is having a lot more fish calling during a period of time than another one. And that could be in relation to the activity or health of the habitat.
Okay, that makes sense.
Yeah. And so I'm doing this at different habitats. I'm looking at this in seagrass meadows, in hard bottom habitats, and in mangrove keys. And to bring it on a further level, I'm also I also have like a set of like connected habitats. So I've got a seagrass meadow that's right next to a hard bottom habitat.
Okay.
But then I also have a seagrass meadow that's just in isolation with no other habitat next to it. And then I've got a seagrass meadow that's got a mangrove key next to it. And this is trying to get at the question of like, are habitats that are in isolation more or less like used by specific fish throughout the seasons?
Gotcha.
And so that's like habitat connectivity, how these habitats are connecting and are being used by fish throughout their life cycle. And so every month I'm going out right before the full moon, because we talked about fish are louder during full and new moon. I just picked the full moon because it's fun. And I'm putting out these recorders. I'm doing the fish surveys. And then picking them up after the full moon to listen and count the number of fish that I see. And I'm doing this from March to November because in March and early spring, that's when I know toadfish are in their mating season. But more so in the fall, I know that's when red drum and snook are making more of their mating season fish calls. So kind of looking at how these habitats too are being used over like across the seasons with the different habitats.
Okay.
Yeah.
So are you doing all of this just over like a single calendar year? Like how long are you running this for?
Right, yeah. So initially it was going to be for a single calendar year, but I had some failure deployments that have caused me to have to run this again for next year. So I'll have 2 years of seasonal
Gotcha.
data.
If that ain't science.
Yeah, exactly. Yeah. And so the very final part of this chapter of my research is like kind of a broader impact, is that I'm hoping to like evaluate the use of this passive acoustic monitoring as either a complementary or even alternative tool to the visual surveys. Because if we can find correlations of like, okay, my mangrove sites are having the highest fish diversity with the visual surveys during November, and that is also showing the same in my acoustic recordings. It might be something that we can use as an alternative tool to monitor these fish communities. And that would be an epic game changer because it's so much less time and money to do that than the like traditional ways.
Okay.
Yeah. And there's also like a lot of up and coming, or not up and coming, but I guess newer technologies, especially with AI and like machine learning, where the computers can actually process the audio recordings for you. So instead of you having to go back and listen to all of the audio recordings and like tag where all of the fish calls are, we have programs and tools that can actually do that for you at a pretty high success rate.
Yeah, one of the, like, AI gets a lot of hate, justifiably, for some things. But this is one of the things that it's genuinely really good for.
Exactly. Yeah. So I think I was going to end this with some research spotlights, but I actually mingled them in with the oyster larvae in the soundscapes, spawning aggregations to researchers monitor grouper and snapper choruses during the specific moon phases like we talked about. And so that allows us to protect key habitats without ever disturbing them. And it's also a lot less invasive than tagging every single fish. And then the last spotlight research was the coral reef health monitoring. So people are studying the soundscape diversity at coral reefs and looking for indicators of like what that sound means for more life on that habitat. And so I actually saw recently on social media some scientists are playing sound underwater of a hypothetical healthy coral reef on some dead reefs to kind of help bring back some of the ecological functions on those reefs, like bringing some of the fish and potentially luring in some of those larvae to reestablish the coral reefs again.
That's really cool.
Yeah. And so the next time you think about the ocean, don't picture silence. Think of a vibrant soundscape full of clicks, pops, and rumbles. And remember, sound isn't just noise, it's information that we can all use. And so if you want to hear real recordings, you can check out online libraries from NOAA or also fishsounds.net. Those have a huge database of where you can Google any type of species and it'll tell you if it makes a sound, and then have little recordings of what they sound like.
Awesome. Hopefully you have fewer, mishaps in the future.
Oh, yes. I hope so too. I hope so
awesome.
too.
But yeah, thanks for this, Fia. This was always really great to hear what you're working on. I love it.
Mm-hmm. Thank you.
With that, this has been episode 165 of I Wish You Were Dead, a podcast about things that used to be alive. My name is Gavin. That has been Fia. And we'll be back with you in a couple of weeks, hopefully with Mike in tow this time. We had to record kind of a weird day because me and my little family were taking a trip to show the rest of Liz's family and friends and stuff out in California, the baby. So we had to record sort of weird, but hopefully that won't be the case next time. But who knows? That's a problem for future Gavin and Fia and Mike to worry about. So until then, take care, everybody. This episode of I Wish You Were Dead was written by Fenella Campanino and hosted by Gavin Davidson, Mike Bryson, and Fenella Campanino. It was sound edited and edited for YouTube by Gavin Davidson. Special thanks to former guests of the pod and to listeners like you.